Alright, welcome back. So you'll notice I'm in the same t-shirt as I was yesterday, and that's because I made both of these videos on the same day. I'm still in workshops today, and I will be back tomorrow, barring any major emergencies. So, I hope you enjoyed the video from yesterday, and I hope you'll enjoy this one. The purpose of this video is to help us learn how to draw atoms of elements based on their information from the periodic table. So now that we know how to find information from the periodic table, we can begin drawing what those atoms look like. We're going to use Bohr's model of the atom for this because it's a lot easier to use than that quantum mechanical model or the wave model that we talked about, you know, the S, the P, the D, and the F, and all that crazy stuff. So we're going to use Bohr's model because it's much more friendly to play with. Alright, so we're going to start off by reminding ourselves of a few things. First of all, and that is the location of protons, neutrons, and electrons. When we're talking about an atom, the protons and the neutrons both are found in the nucleus. The nucleus is the center of the atom. That's also where all the mass is. That's why the atomic mass of the atom is equal to the protons plus the neutrons. A little review from yesterday. We also know that the electrons are found in the electron cloud. This is space where electrons can be found spinning around, flying around, zipping around the nucleus. Okay, so somewhere in that electron cloud. All right, now for Bohr's model, we're going to show those electrons on very specific tracks, but remember that's not how we actually see the atom today. We see those electrons filling certain spaces. Some of them are sphere-shaped, some are dumbbell-shaped, some are really complicated clover leaves and weird odd shapes. But for today's purpose and the purpose of drawing atoms, we're going to use Bohr's model. Okay, so we'll start off by reminding ourselves how many electrons can fit within the energy levels. Now we said there were up to 7 energy levels, but we're only going to look at the first 4 energy levels. And in the first energy level, that energy level can only hold up to 2 electrons. It could have 0, it could have 1, or it could have 2, but it cannot have 3. Okay? It can't have 17. It can only hold 2 electrons. Okay? The second energy level can hold up to 8. It can hold fewer than 8, but it can't hold more than 8. It can hold exactly 8, but no more. Okay? Third energy level can hold 18, and the fourth energy level can hold up to 32 electrons. Alright, so let's talk about what one of these atoms might look like. We're going to start with an atom of hydrogen. Actually, no, I want to start with an atom of lithium. So let's go with lithium. Okay, so starting off, lithium. When I look it up on the periodic table, I find that, first of all, that its symbol is Li. I find that its atomic number is what? Perfect. Its atomic number is 3. And its atomic mass is what? Perfect. 6. Okay? I'm just going to double check myself. See, I already goofed. When I looked at the periodic table, it says that the atomic mass of lithium is actually rounded up to 7. So we'll make that change. It is 7. Remember, if I go too quickly or if I write too quickly, just pause the video, copy down what you can, and then restart. So if you haven't already entered this in, I should have backed up and told you this is on page 17 of your interactive notebook. And today's excuse me, today's title is Drawing Atoms. Okay? So, let's carry on. So lithium has an atomic number of 3 and an atomic mass of 7. Okay, so the atomic number tells me the number of protons and electrons. The atomic mass minus the atomic number tells me the number of neutrons. So I'm going to make a little table for myself. I'm going to tell myself that lithium has 3 protons, 3 electrons, and if I do 7 minus 3, that tells me there are 4 neutrons. So this is how we're going to draw this particular atom. Okay, we're going to start with the protons. Instead of drawing 3 little dots like we have in the past, we're going to make this a little simpler. We're going to do P plus equals 3. That tells me there are 3 protons. I'm also going to tell myself that neutrons, N0, equals 4. And then I'm going to put a little circle around that, and that's going to represent my nucleus. Okay, so there's my nucleus. My nucleus contains 3 protons and 4 neutrons. Now I need to place my electrons. So, how many total electrons are there? There are 3 electrons. How many can fit in the first energy level? Can I put all 3 in the first energy level? No, because it can only hold 2 electrons. So I'll put 2 of those 3 electrons in the first energy level. Now I have to draw a second energy level to place that 3rd electron. Alright, and I can pick anywhere on this circle to go. I'm going to try and find the spot that is farthest away from these 2 though. So I'm going to put mine down here. But it doesn't really matter where on that circle you put those electrons. Okay, so this would be an example of an atom of lithium because it's showing that there are 3 protons and 4 neutrons in the nucleus, and then 3 electrons placed in our outer energy levels. All right, let's try another one. Let's do oxygen. There's one we all know and love. We like to breathe oxygen. Oxygen. Oxygen has a symbol O. Its atomic mass is, looking at my periodic table, 8. And it's, I'm sorry, that's the atomic number. The atomic number is 8, and the atomic mass is 16. Okay, so moving on, I know that there are how many protons? Very good, 8. How many electrons? Very good, 8. And how many neutrons? Well, 16 minus 8, that tells me there are 8 neutrons also. Okay, let's draw our nucleus. We're going to have protons equal to 8, neutrons equal to 8. I'll try and do these in the same colors as I did before. So neutrons is 8. Make my little nucleus here. First energy level. First of all, how many total electrons do we need to place? And this is always the tricky part. Good, we need to place 8 electrons. Can all 8 of them fit in this first energy level? No, only 2 can fit. So I'll place my first 2 in the first energy level. Alright, then I need to draw the second energy level. I started with 8 electrons. I just placed 2 of them, so I'm thinking 8 minus 2, that equals 6 electrons. Can all 6 of those fit in the second energy level? Yes, the second energy level can hold up to 8. I only need to put 6 there, so we're good. Alright, so I'll place my 6 electrons in the second energy level. 1, 2, 3, 4, 5, 6. Excellent. So I'm going to go back and just check to make sure everything's okay. I've got 8 protons. Check. I've got 8 neutrons. Check. I've got 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Check. Very good. Okay, let's try one more. This time I would like for you to do, let's do an atom of chlorine. An atom of chlorine. Alright, so if you had paused your video, you've started back, and let's go over an atom of chlorine. Alright. Chlorine on the periodic table is capital C, lowercase l. It has an atomic number of 17 and an atomic mass of 35. Alright, 35. So, that tells me there are how many protons? I'm going to draw a little box here so I don't get these mixed up. Good, there are 17 protons. How many electrons? Good, 17. And how many neutrons? Well, we had to say 35 minus 17, so that tells us there are 18 neutrons. Okay, let's go ahead and draw our nucleus. What's going to go in our nucleus? Good, protons and neutrons. How many protons are in the nucleus of chlorine? Good, 17. How many neutrons are in the nucleus? Good, 18. Okay. Oh, crud, I keep forgetting the colors. Getting too excited here, folks. Draw my nucleus around there. Okay. how many total electrons do I need to place around the nucleus in this electron cloud? I've got to place 17 of them. Will they all fit in the first energy level? No! I can only put 2 in the first energy level. 1, 2. Alright, so I had 17, I placed 2. How many are left? 15. Good. Can all 15 fit into the second energy level? No! Only 8 can go, so I'm going to place these extra 8. 1, 2, 3, 4, 5, 6, 7, 8. Alright, so how many total electrons have I placed? I just put 8 and had 2 originally, so that's a total of 10. Okay, but I need to put 17. So how many do I have left? Good, I've got 7 left. Can I place all 7 into the third energy level? Yes, because it can hold up to 18. So I'll put my last 7 electrons in this third energy level. 1, 2, 3, 4, 5, 6, 7. Okay, gotta go back and check myself, make sure I'm good. Chlorine, atomic number is 17, so I should have 17 protons in the nucleus. Check. 17 electrons in the electron cloud, or the outer orbitals. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Check. And 18 neutrons in the nucleus. 18 neutrons. Perfect. So, we've done 3 examples on how to draw an atom using information that you gained from the periodic table. Remembering that our protons and our neutrons are located in the nucleus and our electrons are found in that electron cloud, or in these outer energy levels around the nucleus. Okay, so you have some practice problems to work on your own. Be sure to check those with a neighbor once you're done. Have a good day.